Okay. All right, here we go. The last problem, we're using our own data. So these are the data from the Big 5 personality inventory taken by people in the sample, gathered by students in our class. Choose agreeableness, and you're asked to choose any trait you want to in yours and find the mean. And then test the hypothesis using 0.05 that people in our sample have different levels of agreeableness than people in general. Here are the mean and standard deviation for each of the traits. Assume a normal distribution. So let's go ahead and do it. We'll do population 1, people like those in our sample. We'll do population 2, people in general. Our dependent variable that we're measuring is agreeableness. The tails, it says different. It says have different levels of agreeableness. So the tails are going to be two-tailed. The research hypothesis, I see this written right here, so I'm just going to copy it and capitalize it. And here I'm going to copy it again for the null hypothesis. And people in our sample do not have different. I'm going to abbreviate these just so we're clear on these abbreviations too. I'm going to call this H1. That's how we do it in this class mostly. And H0 for the null hypothesis. I usually just type that little O, but that represents a 0 for the empty hypothesis. Next, in order to define the comparison distribution, we have to pull some information from above. So let's go ahead and see what information we have. First of all, what is N for our sample? I know that I can scroll down and see that we have 96 people. So our N is going to be 96. Our M for this sample, we don't know yet. So let's go ahead and calculate it. You'll remember how to do mean. Mean is simply equals the sum of all the scores divided by N. So let's go ahead and do that. Equals sum. And let's get all the scores for agreeableness. I'm going to actually hit Control Shift and my down arrow to select them all. And then I can put my parenthesis and divide by, and let's go up and click in the N cell. Divide by N. So the average score for our sample is this. Mu. Where do we get mu? Mu should always be given in these problems, and I see it's given right up here. Mu is 66.4. The standard deviation is 18, and they're both just stated, so we don't have to do any calculations. Let's go ahead and fill in some of that information. Our center, mu equals, I'm going to type in 66.4. Spread, I think I'll do shape first because it's easy. It's just write the word normal. Excuse me. Spread, I have the 18 here, but I can't compare a group of 96, the average for a group of 96 with the spread for a group of individuals. So I have to do these calculations. So we already know these, but I'm going to write them down again. So variance equals standard deviation squared. Variance for the distribution of means is variance over N. And SEM, or standard deviation for the distribution of means, is the square root of VARM. Let's run those calculations so we know what our spread is going to be. Variance equals standard deviation squared. Right here, well, this one is done. Variance for the distribution of means is variance divided by N. And standard deviation for the distribution of means, now this one is done, is the square root of norm. There we go. Did I do everything right? It looks like this could be right. And I would normally check, but for the sake of time, I'm not going to. I'm going to write SEM equals 1.84. So that step 2 is done. I should continue on. So our cutoff point is going to be using alpha 0.05 for a two-tailed test. And we know from using our calculator, I guess I'll just pull this up, alpha 0.05 for a two-tailed test. We can see here again that it's plus minus 1.96. We'll draw this on our chart. So let's put this in. Alpha equals 0.05, two-tailed. And let me paste that in. There we go. Let's draw this on the chart. 1.96 ZA equals 1.96 negative. And Z equals 1.96. Shading in the tails. Shading in the tails for the reject region. And here is our fail region. Next, we calculate our Z-score. Our Z-score, as you know, is just our sample mean minus our population divided by our spread, which is SEM in this case. Or we could say standard deviation for the distribution of means. Let's type that in. Z equals, let's find our sample mean minus our population mean. Equals, I did something messy there, so let me try that again. Equals our sample mean minus our population mean. And now divided by not this stuff, but our standard deviation for the distribution of means. Wow, a Z-score of minus 12. Remember, if we have greater than 6, we better double check. So I'm going to double check right here. I wrote this down correctly, 18. Did I correctly calculate variance? 18 squared, I did. Did I correctly divide by n? It looks like n12 is the variance. I chose that correctly. I divided by n, 96. So far, we're correct. Did I choose the right number for the square root? I did. So this Z-score of minus 12.53 is accurate. So that I can't even fit on my chart, but using real data, this is right. Minus 12.96 Z equals. Wow. So Z equals minus 12.96. These are real data, you guys. This is a real statistical test. Let me write the Z in there too, just so it's Z equals minus 12.96. So clearly this score is not in the rejection region. It's far, I mean, in the fail region. It's far, far into the shaded rejection region. So we reject HO. And that means we basically cross it off. Let's cross it off. And let's grab our research hypothesis to use in writing our concluding statement. So evidence from this study suggests that people like those in our sample have significantly different, we could say lower if we wanted to be clear, significantly different levels of agreeableness than people in general. And then in parentheses, Z with our sample size 96 equals minus 12.96, P less than 0.05. Because that's what we tested. So that problem is done. So what you're asked to do, I don't give you agreeableness, I give you and ask you to choose one of the other traits and see if it's different for the people in our sample. So that is the end of what we have for our problems. You are also asked to do one problem, a real short one on paper, just so that you get that practice. So are there any questions before we release and you are ready to finish your work on this by Sunday? So any questions on this as I end our recording here?